and namely, that's missing not at random. And here's the missing not at random scenario. In missing not at random scenario, what the doctor is going to do is look out of the door to see whether there are other patients waiting. If there are no other patients waiting, then there's plenty of time to record blood pressure for everybody. But if there are other patients waiting, then there's a flip of a coin, and if that flip comes out to a heads, you record the blood pressure. If not, don't record the blood pressure. And notice that whether patients are waiting is not a variable that would be traditionally collected as part of a study. It would be something that would be unobservable in any data that we finally receive. But let's say we knew whether patients were waiting, we could simulate coin flips now. So when patients are waiting, we will do a coin flip. The coin flip comes out to tails. We won't record blood pressure. If the patients are not waiting, there is no coin flip and the blood pressure will be recorded. Patients are waiting here again, we'll have a coin flip and the coin flip comes out to heads, so we will record the blood pressure. And so on and so forth. Now with missing not at random, the difficulty with unobservable variables is that we just simply don't see them. So whether or not there were other patients waiting is not part of the final data set that we get because it was simply never recorded. And what we end up with is a data set with missing blood pressure values which have a missingness mechanism that's not recorded here. And so when we look at the population with blood pressure missing and with blood pressure not missing, and let's say we were looking at age, we might see that both of them have a very similar distribution, and we can't tell just by looking at this that the data were actually missing not at random, because this looks very similar to what we would see if the data were missing completely at random as well. And so we have with missing not random, the major difference being that the probability that the data are missing, the probability that the blood pressure is not recorded, is not constant. In fact, if in our situation there are other patients waiting, the probability that a blood pressure recording is missing is 0.5, while if there are no other patients waiting, the probability that the blood pressure measurement is missing is 0. But keep in mind that whether or not there are patients waiting is unavailable information, and here the missingness is dependent on that unavailable information. This is missing not at random. And so we've talked about the 3 missing data categories: missing completely at random, missing at random, and missing not at random. Is unfortunately, we cannot generally be sure whether the data are really missing at random or whether the data missingness depends on unobserved predictors. However, it's important to be aware of the different possible missing data categories to understand how, if we drop missing records, we can lead to a biased model.